Hello, my name is Sean Watson. I'm a research associate in the James Watt School of Engineering at the University of Glasgow, and today I'm going to present an overview of a project called THERMOCAL, which investigates the thermophysical properties of Caledonian rocks from Scotland, Northern Ireland and Norway as a means of de-risking geothermal energy developments in those countries. So the THERMOCAL project began in summer of 2025, and it's a 3-year project. It's funded by EPSRC and is a collaboration between the University of Glasgow, the Norwegian University of Science and Technology, Geological Survey of Norway, Queen's University Belfast and the Scottish University's Environmental Research Centre. In addition to the core team, we have support from GCSE Geothermal, the British Geological Survey, the Geological Survey of Northern Ireland, and industry support from THERMOCAL Energy and Eden Geothermal. The rationale behind the THERMOCAL project lies in some shared features between the 3 countries. From a geological perspective, Scotland, Northern Ireland and Norway share continuous Caledonian terrain. The countries also share ambitions for developing geothermal energy projects, whether that be the installation of shallow ground source heat pump systems or the development of deep geothermal energy systems. In terms of demographics, there are rural areas which aren't connected to gas grids in each of the countries, which are potentially conducive to the uptake of ground source heat pump systems. Now, the design of geothermal systems, particularly those which rely on conductive heat transfer, requires knowledge of 3 key thermophysical properties, namely thermal conductivity, volumetric heat capacity, and radiogenic heat production. The vision for the THERMOCAL project is to carry out a systematic measurement campaign of these 3 thermophysical properties of Caledonian lithologies in Scotland, Northern Ireland and Norway, whilst employing unified sampling and analytical methodologies. The aim is to integrate the newly acquired data with existing datasets, which will be used to inform the development of numerical models of the thermal energy output of geothermal systems at particular case study sites of interest. The project will begin by conducting an extensive programme of sampling and data collection. Parallel fieldwork will be carried out in Scotland, Northern Ireland and Norway through 2026 and potentially 2027 to systematically collect representative rock samples for laboratory analysis. In terms of the sites that we're interested in, preference will be given to recent quarry or cutting outcrops rather than natural outcrops, and we'll be targeting lithologies which are present in Scottish, Northern Irish and Norwegian Caledonian terrain and pre-Caledonian basement. Additionally, we will be collecting borehole core samples from core archives at the Geological Survey of Northern Ireland and the British Geological Survey. And the fieldwork will aim to generate approximately 200 rock samples from Scotland, 200 from Norway and 100 from Northern Ireland, with an ambition to collect a statistically representative subset of 5 to 10 samples for each lithology. Following collection of the samples will be transported to the Petrophysical Laboratory of the Geological Survey of Norway. Here, thermal conductivity and volumetric heat capacity will be measured on all 500 of the collected samples. And as well as conducting the measurements, we will be establishing best practice documentation for the collection of the samples, preparation of the samples prior to measurement, and the measurement routines which will be employed. There's also a programme of ring testing with other laboratories which we'll use for verification purposes, and we'll be seeking to quantify uncertainties within the measurement procedures. As well as determining thermal conductivity and volumetric heat capacity, we will also be determining and mapping radiogenic heat production. This will be conducted at 3 different scales. First, regional survey, then local surveys, and then site-specific surveys will be conducted. So to begin at a regional scale, we will be investigating existing airborne radiometric data from Northern Ireland and Norway, with the coverage shown on figures here, and we'll be conducting a new airborne radiometric survey. One potential site for this is the Isle of Arran in the Firth of Clyde on the west coast of Scotland. We will also be conducting ground-based surveys using portable devices such as a handheld gamma ray spectrometer and a backpack system. This will allow us to measure uranium, thorium, potassium at either point locations or across a traverse, which will allow us to build up coverage over a local area. Then at a site-specific level, we will be conducting new downhole radiometric surveys and existing boreholes across Northern Ireland, as well as analysing existing data held at the Norwegian Geological Survey. So once we have completed the fieldwork and carried out the measurement campaign and compiled the dataset on thermal conductivity, volumetric capacity and radiogenic heat production, we will use this data to inform the development of numerical models of geothermal systems at particular case study sites, and these numerical models will be evaluating the thermal energy output and performance of such systems. And now, just to round off, please get in touch and engage with the project. We have a website, a dedicated email address, and a LinkedIn profile. So if you have any questions or thoughts, then we would love to hear from you. Thank you very much for listening.